Hi there! Welcome to your lesson on arc length. In this diagram of a circle here, notice that the arc is marked in red here. It is like a piece of the circumference of the circle. Alright, so arc is just a piece of the exterior kind of perimeter of a circle. Alright. Hey, doggy. Okay, so we have arc length. The length of an arc is, as I just said, part of the circumference of a circle. So let's check this out. Here's a circle. I have split the circle in half by putting a 100-degree angle here. So basically I've drawn in the diameter. Now when I've drawn the diameter, if I talk about the circle, it's kind of split into two halves. So this C here is going to represent the circumference. If the entire circumference is 40, then what would you say is the length from here to here? I hope that answer is pretty obvious. It's 20, because clearly we are going halfway around and the full circumference is 40. So 20 is an obvious answer, but let's set this up in the way we're going to look at arc length. So to find the arc length, rather than jumping right to the answer of 20, because we know half of 40 is 20, how do you get the half? Well, you get the half by saying I have 180 out of a possible 360, right? I have 180 degrees out of the possible full 360 in a circle. And that 180 over 360 is what turns into a half, right? Because 180 over 360 is a half. So it's telling us we have gone halfway around the circle, and therefore half of 40 is 20. And again, of course, we made that calculation in our head, but sometimes the portion of the circle we have is not so obvious. So knowing this calculation is key. Let's try another one. So here we have another circle, and again, I've put a diameter in, and that angle that's represented here is 180. It tells us our circumference is 38. Therefore, how long is the arc length in this one if you went just, that distance around the circle? Again, the calculation we're going to do is 180 out of 360. Okie dokie, so we know again that we have half. The arc represents half the distance around the circle. So half of 38 is 19. Again, just like the last one, pretty obvious. How about this next one here? We have an angle of 120 as our central angle, and we want to know the length of this arc. This one right here, that arc. And we know the whole circumference is 45. So you're thinking in your head, well, maybe you've already figured it out. Awesome. But maybe if we approach it this way, we can say, okay, what portion is 120 out of the whole 360 in a circle? So 120 divided by 360, well, that's 1/3. 120 is 1/3 of the way around the circle. So if we're going 1/3 of the way, then we're going to do 1/3 of the circumference. So 1/3 of the circumference gives us 15. Again, if you came up with that pretty quickly in your own head, fantastic, but let's keep approaching it by making this fraction. Next one, this one here. Circumference, 60. Central angle, 60 degrees. So how long is this arc going to be here? All right, again, 60 out of 360. We're saying what portion of the whole circle do we have? We have 60 out of the possible 360, which is 1/6. That makes sense, because 60 goes into 366 times. We have 1/6, and 1/6 of 60, 1/6 of the whole circumference is 10. All right, how about this one right here? Circumference is 63, the angle is 40. So what portion of the circle do we have now? Well, 40 out of 360 is 1/9. Or so maybe you're thinking of the opposite way in your head, 360 divided by 40, and then you say, ooh, 9. So there's 9 of those in the circle. But this is the fraction we're getting, 1/9. So 1/9 of the whole 63 circumference is 7. Well done if you're on a roll here. Okay, let's do a little exploration into the same idea. So here we have a full circle. It says 360 degrees. And the length of the corresponding arc is 2 pi r. That means, well, in this case, we have 360 degrees. It means the whole circumference. So when it talks about this arc, it means the whole circumference. And that is the formula for finding the circumference of a circle, 2 pi r. Now, we have 270 degrees. So we're talking about, oh, sorry, there's that full circle. Now we're talking about just this arc. So what portion of the circle do you have? What are you going to multiply the circumference by? Now we don't have a number for circumference, but we're going to use 2 pi r. So 2 pi r has to be multiplied by whatever portion of the circle that is. So what portion is that? Well, 270 out of 360 reduced is 3/4. And that makes sense. We can see here, this is 3/4 of the way around the circle. Again, 270 divided by 360. So we have 3/4 of the circumference. Look at the next one. We're back to 180. So we're talking about this arc. What portion of the circumference do we have? How would you write that out here? Well, that is half times 2 pi r, right? We have now half of the whole circumference. And again, to calculate this half is obvious, but it would be 180 divided by 360, gives us that half. Next one, now we have a 90-degree angle. This is the arc we're talking about. What portion of the circle do you have now? Well, we have 1/4 of the circle. Clearly, this is a quarter. Again, to find that quarter value, 90 over 360 gives us 1/4. So we have 1/4 of the circumference. Next one, 4. Okay, so what are you going to do 45? What portion of the circle is that? Let's check. Well, that was my dog answering the question, and he said, you need to do 45 over 360, because it tells you what portion 45 is out of 360, and it is 1/8. So he was exactly right. I hope you understood his barks. So, what are we looking at? So, therefore, we have 1/8 times 2 pi r. We have 1/8 of the full circumference here. Next one. Now we're talking about 1 degree. Wow, okay, 1 degree. It gets a little weird at 1 degree, but okay, let's figure it out. Okay, in this case, 1 out of 360. We have 1/360th of the circle. So therefore, we're going to have 1/360th of the circumference. So 1/360th times 2 pi r. Finally, and this is what we often do in math, right? We look for a pattern, kind of an approach to something, and then we generalize it. Now we say any angle. This is alpha. So any angle alpha, what would be the equation for finding the arc length if we had any angle? All right, same approach. Alpha as a portion of 360, right? What portion of 360 is that? And then that's our formula. Alpha over 360 times the circumference. Whatever portion out of 360 times the circumference. That is our arc length formula. Well done. So let's continue our exploration. Here we have a window, which is a semicircle of radius 12. So each of these lengths here to the center is 12. It is divided into 6 congruent sections. That means 6 identical sections, as shown in the diagram. Find the length of the arc of the entire semicircular window. How long is this arc? Use the little formula we just came up with, right? So by that formula, we know that we have a semicircle, so we have exactly half the circle, right? So half the circle means we're going to have half the circumference. And plugging in those values, we know the radius is 12, so r is replaced by 12. We have half of that, and that becomes 12 pi. The half and the 2 cancel, and you're left with 12 pi. So that's the length around here, from A to B. Okay, let's look at 3. Find the length of the arc of one of the 6 sections of the window. Just one of the 6 sections, and they're all congruent, remember. Okay, in this case, we know each of these sections is 1/6 of the half. So I just did 1/6 times half, and then that times the circumference. 1/6 times half is 1/12, and that makes sense. If these are each 1/6 of a half of a circle, they are 1/12 of the entire circle. So 1/12 of the entire circumference here gives us a value of 2 pi. And looking at this 12 pi and this 2 pi, that makes sense as well. 2 pi is 1/6 of 12 pi. So if this was all 12 pi before, now we have exactly 1/6 of that to represent one of these lengths, which makes sense. Try number 4. Okay, if it says if the window is divided into sections with a central angle of 1 degree, okay, this was divided into 6 sections, but now each of the sections has an angle of 1 degree. Find the length of the arc of such a window section. What would be the length of the arc if each of these was 1 degree, this angle? Okay, so now we're talking about 1/360th of the circle, and then times the circumference, right? So again, we have 1/360th times the circumference, and that gives us 24 pi over 360. Finally, number 5. Find the length of the arc of a window section if its central angle was alpha. So again, we're going to the general case now. We don't know what the angle is. It's some mysterious value, unknown value, alpha. So what would be the general equation here? Let's check. In this case, again, alpha over 360 times 2 pi r, the same formula we were just talking about. And that can be, in our case, simplified to this using the 12 for radius, and things simplified to that. All right, great job if you made it through that little exploration and investigation. After that, I'm sure you have a very good intuitive feel for what an arc length is as a portion of a circumference. So let's apply it. Here's the formula. To find the arc length, we just do the angle that we're looking at, the central angle, as a portion of 360 times the circumference, because we're just basically taking a piece of the circumference using that formula. Let's try it on this one here. So try it on this problem. Here is a solution. I hope you came up with 4.19 as well. Notice that they give you kind of two approaches here. One is exactly the formula we're just looking at. 1/3 comes from 120 over 360 times the circumference. Over here it looks a little different. That comes from the fact that our formula can be presented as a portion of 180 degrees as well. So instead of using 2 pi r, we just use pi r, which is actually half of a circle, and therefore change this to 180. Not super important, you know both, but to understand the connection between the two formulas, very good. All right, let's try another one. Find the length of arc AB in this circle with the given parts. Okay, arc length, using our formula, we have 105 degrees out of 360 times the full circumference, so what this portion of the circumference, and that works out to this value here. I left a pi in the answer here. Of course, you can go further and leave it as a decimal. But when we leave pi, our answer is actually more precise because pi is a irrational number. A decimal that has no patterns and does not repeat goes forever. So if we approximate pi using, for example, 3.14, we have rounded away a bunch of digits of pi, and therefore this answer is less precise than this one. Okay, let's try this one. What's the length of arc AB in this circle? In this case, we have 85 degrees out of 360, so that is the portion of the circle we're talking about here. Multiply that by the circumference, 2 pi, 3, radius is 3, and we get 4.45. Let's try a couple more. How about here? How long is arc AB in this one? And this is a typo. That B should be right over here. So how long is this arc here? Okay, in this case, I hope you notice that the angle we're given is here. So if that's 240, 360 minus 240, this angle here must be 120. So it's really important that instead of using 240, you use 120. 120 out of 360 is this portion of the circle here, and we know that's 1/3. So 1/3 of the circumference equals this. A couple more. Here we have a circle, and we're looking for the length of arc ABC. So now notice it doesn't say AC, it says ABC, so it means go the long way around here. How long is that arc? Again, it's important to subtract angles here, because we're looking, since we're going a long way around, we need to know this angle here. 360 minus 110 is 250 for that angle, and then use our formula here. Check your work, final answer right here. Great job. You are now a master of arc length, and you truly understand that an arc length is just a piece or portion of the full circumference of a circle. See you soon.